Thank you, Tim, and good afternoon, everybody, and thank you for joining the webinar today. Next slide, thank you. I will start with a very brief introduction to the board. Stephen Hunt is the Executive Chairman, and Stephen has been on listed Australian entities as a director for in excess of 20 years and is currently a director of American Pacific Borates and started his working life with BHP. Daniel Eddington, together with Stephen, started the company, and Daniel's had over 20 years experience in the financial sector across a multiple of businesses and sectors, and is currently a director of Jade Gas. Our newest addition to the board, Stephanie Moroz. Stephanie has literally just joined us, and we're thrilled to have her on board. Stephanie's got 25 years plus experience in the hydrogen, battery and nanomaterials space, and also brings with her a wealth of corporate experience. So we welcome Stephanie to the board. Stephanie is currently the Innovation Manager with Global Energy Play EDL based out of Brisbane. Myself, I've been with Sparc now for just on 12 months. I had about 40 years worth of experience in the global multinational space, in the coating space with both AkzoNobel and Sherwin-Williams. And I ran businesses both here in Australasia and based out of Asia and the UK. And my strength has particularly been not only in managing businesses, but particularly driving growth strategies within those businesses. As you can see, our market cap at the moment is sitting around 60 million. We've had something of a journey of more recent times, and our shares at the moment are held fairly tightly with our strategic shareholder in the University of Adelaide still holding 8% of shareholding in the business, and directors and management hold about 15% equity in the business. Next slide, thanks, Tim. Our objective, we're very much a technology play at the moment, and it's very much about introducing new technologies to industry that are both disruptive and also serve to enhance existing industries. We're a relatively new business. The business was listed in November 2020, and it was listed on the basis of a graphene technology platform that came to us courtesy of the University of Adelaide. And as I touched on in the last slide, the University of Adelaide still holds about 8% in the company, is indeed a strategic shareholder in the company. Shares are tightly held, about 20%, about 20 shareholders hold about 40% of the shares in the company at the moment, so tightly held share registry. And at Sparc, we've arrived at focusing on two specific areas where we want to introduce new technology that's both enhancing and disruptive. And those two areas are graphene and energy. And it's important to also note that whilst these are two primary areas of focus, there is indeed a lot of synergy between these areas, which I'll touch on through the course of the presentation. Next slide, thanks, Tim. Graphene, well, what is graphene? Graphene is an allotrope of carbon, which is just a fancy technical term for a derivative of carbon. It was discovered in 2004, which is a little hard to get your head around because you think that with carbon being so ubiquitous within our industries and just in general that it might have been stumbled across previously. But graphene was actually discovered in 2004 at the University of Manchester. And so significant was that discovery that the two physicists involved were actually awarded the Nobel Prize for Physics in 2010. So within a very short period of time, they were awarded that prize. So graphene has been touted for a number of years now as a wonder product, and that's because it has a vast array of fantastic physical properties and characteristics. And I'll just very briefly touch on those before we talk about how we seek to employ graphene as a building product in our modern society. First of all, it's got high mechanical strength, weight for weight and thickness for thickness. Graphene is 200 times stronger than steel. A little bit hard to get your head around. In terms of surface area to weight, 1 gram of graphene has a surface area in excess of 2,000 square meters. It's highly electrically conductive, it's highly thermally conductive, it's antibacterial and antimicrobial in performance, and it's also hydrophobic. So it has a vast array of properties that we are now seeking to exploit in industry. And indeed, the race is on, given all of these characteristics, for industry to adopt graphene as a material going forward. Next slide, thanks, Tim. So with this vast array of characteristics, we will indeed see graphene over a period of time incorporated into most of the modern products that we currently consume, and indeed it will be the precursor to new products being introduced to market as well. So at the moment, we're seeing research and development happen in building material spaces for graphene. It's already been adopted quite broadly in the electronics space. For instance, it's been incorporated into screens, mobile equipment. We're seeing it in battery plays at the moment. And it's also being employed in medical equipment, biosensors and the like. Because of all of these particular characteristics and the ability to play fairly ubiquitously with graphene, what's incredibly important is to be very, very focused in terms of what one wants to achieve in a graphene play. So at Sparc, we've arrived at wanting to participate robustly in what we call the building materials sector. And the reason for doing that is that we believe we've got some proprietary technology and the acumen to be able to add value in this particular space. Very importantly, though, this is a multi-billion-dollar sector. It's established and it's global in its characteristics, and it therefore offers very significant commercial opportunities for us in the event that we deliver the products that we are looking to deliver. The customers within this segment invariably have very large ESG objectives, and again, graphene can play a considerable role in helping our target customers deliver their ESG objectives. Sparc Graphene is concerned with what we call the formulation and adoption of graphene-based additives, and I'll sheet that graphene-based additives piece home on the next slide. But we're specifically looking at targeting coatings, concrete, and composites at the moment. Now, in the graphene space, there's a lot of literature. There's something like 2 million sites that you can go and visit graphene. There's a lot of people producing graphene at the moment and foisting it on customers and expecting their customers to be able to do something with it. We're very different from others in the graphene space. Our modus operandi is to actually take graphene as a raw material and to actually formulate with it and to add value in what we would consider to be very targeted end uses. So what we're looking to do at the moment is to liaise with targeted customers, arrive at what they consider to be opportunities or indeed problems that need to be solved, and formulate products for a targeted end use. Now, a lot within the graphene space at the moment is simply producing graphene and dropping it into what we would call very simple dispersions with a primary want to simply aid handleability. What we're doing is looking at producing a formulated material based on graphene that delivers a specific outcome for our targeted customers. Now, because of that, we've actually elected at this point in time not to be a graphene producer per se, and that's because we don't want to be captive to a graphene production process that dictates the type of graphene that we import into the products that we formulate. So again, we differentiate greatly from others in the graphene space in that, one, we don't produce graphene, and two, we see graphene as a raw material with which to formulate for specific targeted end users for targeted customers and outcomes. In terms of where we're at the moment, after only 12 months or a little bit over 12 months, we've got a fully functional, purpose-built and designed research and development facility now in South Australia that's tooled up with all of the necessary equipment and folk to be able to drive all of that equipment. In addition to our own R&D activities in-house, we've got a number of collaborative arrangements in place with Australian universities. We spend a lot of money on R&D, both in-house and also too with Australian universities. And we collaborate with the likes of RMIT, Flinders University, Melbourne University, University of Adelaide, of course, as a strategic stakeholder in the business. So we've got plenty of fallback in terms of university support that we can draw upon. In terms of our capability set at the moment and what we're taking to industry, we're taking to industry that we have developed, and this is indeed quite unique, an inherent understanding of graphene and what is known as a characterization of graphene. So what is a relatively new material, we actually inherently understand what graphene is. And to coin an old phrase, oils ain't oils, graphene most certainly isn't graphene. And you really need to understand the characteristics of each graphene material that you're looking at in order to import those characteristics that you wish to take to a targeted end use. We obviously know how to formulate graphene-based products, both in terms of materials that can be readily dropped into what are already commercially available products, or indeed in some instances, we're able to formulate finished coatings that will serve to be disruptive in the coating space going forward. Very importantly and critically, talking to our customers, they want to know about our ability to both manufacture and scale up in this space. It's very important because graphene can present some problems in terms of handleability, and we're working through those issues with customers. We have significant R&D capabilities that we've built up with time. And very importantly, I've said here, active program regards patenting. Indeed, we've got a very aggressive program in terms of patenting, and we hope to close out some patents in the not too distant future. Next slide, thanks, Tim. Based on work to date, we're very confident about being able to deliver some major outcomes in the coating space in the not too distant future. We're entertaining a number of global coatings companies at the moment and looking to advance our position with them. As I just touched on, we've currently got discussions in place with a number of global paint companies, and the objective is to have formal collaborative technical agreements in place very soon as a precursor to commercial arrangements. And those commercial arrangements could take the form of either selling graphene-based additives to those global multinational coatings companies, or indeed licensing know-how. Critically in this space, we've got direct access to these customers. We know who they are and they know us, and we've got the expertise to be able to carry the day. And our approach in coatings will now be taken into both the composites and concrete markets, which we're also targeting. And that approach is very much about formulating for a targeted end use, doing lots of testing to recognised industry standards, and employing the appropriate subject matter experts to be able to carry the arguments with those customers. So we believe we've got a very good position in the graphene place or space at the moment to be able to advance our commercial aspirations there. Next slide, thanks, Tim. Sparc Green Hydrogen. It'd be fair to say that in terms of graphene, we're primarily looking at enhancing our customers' products that are currently in place. With our Sparc Green Hydrogen play, we're very much looking at introducing something that is genuinely disruptive in the industry. And by disruptive, we're introducing a process called photocatalytic hydrogen production. And this is a process by which we simply have a unique means of capturing the sun's input, which means that we don't need to displace or generate renewable energy in order to produce our green hydrogen, nor do we need to employ what is typically used in this space at the moment, which is called electrolysis. So we genuinely have something that's disruptive in this space. Might go straight to the next slide, thanks, Tim, and start to show some graphics in this space. You may have heard a lot about the colours of hydrogen, starting with grey hydrogen. This is hydrogen that's produced courtesy of what they call steam reformation. And this is simply where you take fossil fuels, subject it to steam, and split hydrogen out courtesy of that process. Blue hydrogen is exactly the same type of process, but it captures or entails the introduction of carbon capture, and hence the name blue hydrogen. It's not seen as being as environmentally unfriendly as grey hydrogen. Green hydrogen, which I just touched on, is where renewable energies are used to produce hydrogen, courtesy of the introduction of electrolysis. And then we have our Sparc green hydrogen, which is all about the unique means by which we seek to capture the sun's input into a photocatalytic material. Next slide, thanks, Tim. Okay, and this is where it all happens. What we have front and center in terms of this process is a reactor. This reactor is where the photocatalytic material resides. And what we're all about with regards to this process is optimizing the way the sun interacts with the photocatalytic materials that reside within this reactor. Now, it's worth also shooting home the fact too that photocatalytic chemistry is not new to industry, but this process is all about what we call the optimization of sun to hydrogen ratio, or the optimization of that particular ratio. We have a patented position with regards to the way we will engage the solar interaction with the reactor, and we also have a patented position with regards to the photocatalytic material that sits within the reactor. And courtesy of that, we'll be able to deliver something in this space which is entirely new and, as I said earlier, disruptive. Next slide, thanks, Tim.
Mike, I just might interrupt you 1 second,
Yeah,
and just suggest we've probably got a couple of minutes left, if that's okay. Okay,
thank you, Tar. In terms of what is typically captured as green hydrogen at the moment, and what we will indeed see play out in the near term, is what we call green hydrogen through the use of renewables and electrolysis. So this is simply using, excuse me, solar or wind farms to generate renewable and to be able to drive an electrolysis process that subsequently drives the creation of hydrogen. And if you look at this particular process, our process doesn't need to generate renewables, doesn't need the electrolysis, and simply has a unique means by which we capture the sun as it interacts with that photocatalysis that sits within our unique reactor. Next slide, thanks, Tim. This is I guess the slide that really sheets it home. If you look across all the different colours of hydrogen that we touched on in the earlier slide, it really does show the competitive advantage or the unique selling proposition that Sparc Green Hydrogen has relative to others. So we're a unique process in that we're all about photocatalysis, which is, again, a technology that's already well understood, but hasn't been able to be optimized. So our process is very much about optimization. Our feedstock is water. And interestingly, just an interesting fact, for every 9 litres of water that's introduced into the process, a kilogram of hydrogen is produced. The byproduct of our process is pure oxygen. So there's no nasties come out of our process. Carbon emissions are therefore nil. Location is only restricted by what solar resources are available. And one of the things that's very unique also about this particular process, because it doesn't need renewables to be produced, because it doesn't need large-scale electrolysis to be supported and driven, our process is also eminently scalable. So that's also a unique selling feature as well. The next key milestone with regards to this project will come circa the middle of this year, when our preliminary techno-economic analysis will be produced. And our expectation to this point in time is that we will actually be confirming to the market our ability to deliver hydrogen at the lower end of the cost curve. And of course, the government has a statement out there at the moment that they'd like to see hydrogen sitting around that $2 per kilo position. And that's certainly the minimum objective that we're setting ourselves with regards to this position. What's important is, so I was just going to offer, Tim, that what is important is that, as we touched on earlier, I touched on earlier, graphene is able to be employed through the hydrogen process. There are a number of areas that we're exploring at the moment, and we're working through projects. So there is most definitely synergy in that space in terms of graphene interacting with our hydrogen play as well.
Thanks, Mike. We are out of time. I'm sorry. There are several questions there online. If you could answer those just by typing the answers in online, that'd be most appreciated. It's a really interesting presentation. I appreciate you had a lot to get through. So thank you for your time.
Good. And thanks very much, Tim. Thank you, everyone.